Hi, algebra class. We're going to get into independent and dependent events in regards to probability. So let's get our definitions down first. What are independent events? Independent events are when there is one event where one event does not affect the probability of the other. What are dependent events? That is the complete opposite, where one event does affect the probability of the other. So go ahead and make sure you're taking good notes. Again, this note sheet I gave to you before you left. So let's talk a little bit more about independent events. So independent events could be something like coin tosses. So if you toss a coin and you're going to toss a coin twice, what you got on the first toss has no bearing on what's going to happen in the second toss. Could have got heads, it could have got tails, it doesn't really matter, right? Because when you toss it the second time, it's its own new toss. Whereas, for example, picture if you have a bag of different colored marbles and you reach in and grab out a marble. Now, if you put that marble back in and you're going to draw again, then those are independent events. They don't affect each other. But if I were to keep that marble out on the first pull and not put it back in, that does affect what I'm going to pull the next time. I have a less likely chance of getting whatever that color was that I pulled out. So you have to look at each dependent and see, are they independent of each other, or does what you do on one affect what you do on the other? So let's take a look at example 1. It says tell where, it doesn't say tell where, does it? Tell whether each set of events is independent or dependent. Explain your answer. You select a card from a standard deck of cards and hold it. A friend selects another card from the same deck. You can see that your answer is actually written right here. It is dependent because if I pull out a Jack of Hearts and I hold that and I don't put it back in, when my friend draws out of it, she can't get the Jack of Hearts. So her probability of pulling certain cards is different now. Okay, because she has fewer cards that she can choose. Okay, let's go over here and look at B. You toss a coin and it lands heads up. You toss the coin, same one again, and it lands heads up. Okay, so what you did when you tossed it the second time, it didn't matter what you got the first time. It's the same coin, you're going to toss it. So those are independent events. The result of the first toss did not affect the result of the second toss. Okay, so let's look a little bit deeper here now at some of those marble situations that I was talking about. An experiment consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. So first of all, those in of itself are independent events because I put the marble back in. So my chances of whatever I'm going to pull out are exactly the same the first time or the second time. So let's see though, because it says the bag contains 3 red and 12 green. What is the probability of selecting a red marble and then a green marble? So when you're going to do these probabilities, what you're going to do is multiply the probability of each event. So what is the probability of selecting a red marble and then a green? I'm just writing underneath it. I'm going to put my stuff right up here. So when we do that, there's a total of 15 marbles in the bag. So that's the bottom of my fraction. I got 15 marbles. And if I'm seeing what are the probability of pulling out a red, well, the red, there were 3 of them. So I have 3 15ths for that. I'm going to multiply that by the probability of pulling a green out. And remember, I put that red one back in. That's a very important word to start recognizing in your problems. So I still have 15 marbles in there. But now my probability of pulling out a green one is 12. And after I multiply those, I'm going to have my answer. Since we are multiplying fractions, I can cross cancel, okay? Because I can take this 3 over 15, that alone will reduce, I'm going to write it down here, to 1 over 5, because you can divide that by 3, and you can divide that by 3 and get 1/5. 12 15ths can also be divided by 3, so I'm going to do that, and I'm going to get 4/5. Now, nothing else on the top will cross cancel or reduce with anything on the bottom. So you can either reduce, or if that didn't work, you could cross cancel. 1 times 4, 5 times 5 is 25. That is the probability of that event happening. So let's look over here. A coin is tossed 4 times. So we have 4 events. 1, 2, 3, 4. What is the probability of getting 4 heads in a row? Well, when I'm tossing the coin for the first time, the probability of getting heads is 1 out of 2, right? I have 2 possibilities. It's going to be heads or tails. And one of those is going to be heads. Well, that probability doesn't change because it's the same coin. My chances are the same for all 4 tosses. And again, we do the same thing we did over here. We are going to multiply those possibilities. 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. And that is your chance of getting 4 heads in a row, 1 out of 16. All right, and lastly, we have a snack cart that has 6 bags of pretzels and 10 bags of chips. Grant selects a bag at random, and then Iris selects a bag at random. What is the probability that Grant will select a bag of pretzels and Iris will select a bag of chips? Well, these are dependent. Oops, I'm not on the screen, am I? Let's get that down. These are dependent. I have a total for the first one. Who's the first one? Grant. And then we have Iris. So when Grant is pulling out, there's a total of 16 bags here. I always want my total in the bottom. And what are the probability Grant selects pretzels? So there were 6 bags of pretzels. So 6 out of 16. But see, now when I get over here to Iris, there's not 16 bags in there anymore because Grant took out a bag of pretzels. Okay, so I have now 15 in there. And how many of those 15 were chips? 10. Okay, because we're assuming that Grant got his pretzels. So now that's slightly different. When they're dependent events, the probability shifts. Okay, he didn't put the chips back in. That wouldn't have made sense, actually. And so let's cross cancel and reduce. First, let's simplify them. Divide them by 2. Get 3/8. Divide by 5. Get 2/3. Can we still cross cancel? Yes, we can. 3 over 3 is 1 and 1. 2 and 8, divide them each by 2, and you get 1 over 4. I am left with 1 times 1, which is 1, and 4 times 1, which is 4. And that is all she wrote for today's lesson. Feel free to, again, re-listen to the parts that may have caused you some confusion. Take care. God bless.